Hi everyone, so my name is Kanpanit.
My name is Sandra.
And my name is Monayo.
And today we're going to be proving the acceleration of Earth's gravity using the 4 equations of motion. And today, the stuff that we have to prove this is we have a measuring tape, we have an electronic balance, and we also have a ball. And we will also be timing using a stopwatch.
Yes, okay.
Let's go. Okay, so first we're going to be measuring the weight of the ball.
Woohoo!
Okay, so the weight of the ball is 9 grams.
8.
Okay, so here we have our displacement time graph, the time in seconds and the displacement in meters. And we're going to be dropping the ball from a distance that we're going to plot in the graph and the time it takes from the starting point to when it reaches the ground.
Okay, so now we're going to be dropping the ball from the distance of 0.1 meter.
0.1 meter, Mr. Tom. In 3, 2, 1.
Okay, so now we're going to be dropping the ball from the distance of 0.1 meter.
0.1 meters, Mr. Tom. In 3, 2, 1.
We're going to be repeating the step until we reach 1 meter. Okay, so now we're going to be dropping a ball from a distance of 1 meters and we're going to time it. 8. Okay, so now we're going to be dropping a ball from a distance of 1 meters and we're going to time it. 3, 2, 1.
Hi, Mr. John. So now we have timed and plotted the graph to 0.1 meter to 1 meter. And we are going to be finding the velocity, Mr. John.
So first we'll be finding the velocity of the displacement time graph, and we will be choosing one of the points, which is the final point at 1 meter, and it took 0.32 seconds. So the formula to find the velocity is basically the distance over the time, which is delta S divided by delta T. So first we will substitute in the numbers, which is 1 meter at the top divided by the time, which is 0.32 seconds. After we plug it in the calculator, or after we calculate, we will get a velocity of 3.125. So the first method that we can use to find the acceleration of Earth's gravity is using the formula A equals to final velocity minus initial velocity divided by the time. So when we substitute in the number, we already have the final velocity, which is 3.125 meter per second, minus 0, since that is the initial velocity, divided by the time, which is 0.32. After calculating, we will get 9.77 meter per second squared, or around about 9.8 meter per second squared. So the second method that we can use is using one of the 4 equations of motion, which is V equals to U plus AT. V for final velocity, U for initial, A for the acceleration, and T for time. So we already found the value for V, which is 3.125, equals to 0, which is the initial velocity, plus A times 0.32 seconds, which is our time. So after we calculate and we divide the numbers, our acceleration will be 9.77 meter per second squared, the same as the answer we got before, which rounds about 9.8 meter per second squared. These two formulas or equation are basically the same, just written in 2 different forms. Now the values may not be exactly 9.81 meter per second squared, since there could be an error while calculating the time when it drops to the ground, or when we are measuring the distance of the height of the ball from the starting point to the ending point. There's actually another way where we can calculate the Earth's gravitational acceleration by using the formula F equals to G m times m divided by r squared. So the capital G is the gravitational constant, the big M is the mass of the Earth, the small m is the mass of the object on Earth, and r is basically the radius of the Earth. So as you can see here, the force that we're talking about is basically the weight, which is m times g. So since there is both m's on both sides, we can cut it out. So here we have the substituted values for the gravitational constant and the mass of the Earth and the radius of the Earth. And after we calculate and we divide, we will get a value of 9.81 meter per second squared, which is exactly the Earth's gravitational acceleration. However, since we cannot prove the value of the mass of the Earth and the radius of the Earth, we'll be sticking to the first method.
Bye-bye! Bye! Bye!
Okay.
Bye-bye!